Assalamualaikum and hi, my name is Suraya binti Kasim. I would like to start this project presentation with the introductions. So, in general, flash flood is the most devastating natural hydrological disaster that occur in every country, and Malaysia too is not excluded in experiencing major flood disaster. It is occurs by an overflow of water onto a normally dry area, which usually affects by natural factors such as rainstorms, slow water runoff, broken dams, and extreme weather conditions, and human factors such as logging, settlement, and agriculture. Next is about the background of study. We are required to design an ideal stormwater drainage system at the given area, which located at Taman University, Parit Raja, Batu Pahat. Based on the observation at the proposed area, the approximate top width, bottom width, and depth of the drain are 4.50 meters, 4.20 meters, and 1.7 meters respectively. The topography of Taman University, Parit Raja can be considered as flat. Also, the soil type of study area is silky clay type with low infiltration capacity. In this case, flooding at the roadside also possible to be occurred. The objective of this project are: first, to investigate and analyze the layout at study area and propose the drainage layout of the study area with appropriate and well-designed drains. Next is to design the drain by referring Urban Stormwater Management Manual (MSMA) second edition in order to solve the problems. Next is to relate these issues with the applications of rational method in real-life problem solving. And the last one is to apply the concept of engineering hydrology in urban stormwater design. We move to the groundwater level. Groundwater level can be defined as the level either below ground or above ordnance datum at which soil or rock is saturated. At the proposed area, the circumstance at the top layers of soil is dominated by clay in which its permeability is small, so the water is difficult to infiltrate the ground. So, well technique is designed. The drains based on the flat area problems. Layers of bedrock and low infiltration rate are required to overcome these issues. The good prospects for the groundwater recharge system to increase the capability of groundwater. The recharge system also will contribute to the drainage system by reducing the volume of rainfall runoff using the recharge well technique. That is all from me. Thank you.
Hello, my name is Tan Bengal. In this video, I'll present about the methodology of our group project. First of all, for our project, we refer to the Urban Stormwater Management Manual for Malaysia, MASMA Edition 2, and basically based on the Chapter 2, Peak Discharge Estimation. We use the rational method to design and to find the peak discharge Q. Here is the general procedure for estimating peak flow using the rational method. First of all, we select design ARI for drainage system. After that, we divide the such catchment into segment of homogeneous land use or surface flow. After that, we estimate the time of concentration TC. What we do, we estimate the overland flow time, estimate the flow times for all other flow components within the subcatchment such as the curb girders, pipes and channel and etc. After that, we determine the average strength for intensity. We calculate the I for design ARI and duration D equal to the times of concentration from IDF data for area of interest. The next step is estimate the C value for each segment if there are different land use. The C here is runoff coefficient. After that, we calculate the average runoff coefficient using the equation, which C average is equal to sum of the Cj, which is the runoff coefficient of segment I, times the Aj, area of segment I, and then the sum from j equal to 1 until the total number of segment n, and divide with the area of segment. After that, we calculate the peak flow rate Q for the subcatchment using this formula. Q is equal to CIA over 360, which here Q is peak flow, which we want to find. C is the runoff coefficient, which is based on the table 2.5. I is the average rainfall intensity, and the A is drainage area. Here is table 2.1, which shows the equation to estimate the time of concentration. Here is table 2.2, which shows the value of Horton's roughness, and here is table 2.3, which shows the value of Manning's roughness coefficient and for open drainage and pipe. Here is table 2.5, which shows the recommended runoff coefficient for various land use, which at the flowchart part is at the last. And here is the design chart that the normal graph for the estimation of overland flow time for the ship flow. Here is the portion of the table 2.1b, which shows the fitting constant for the IDF empirical equation for the different location in Malaysia for high ARIs between 2 and 100 years and strong duration from 5 minutes to 72 hours. So in our project is Johor State and number 6, station number 6, sector JPS Batu Pahat, and we use the constant here. And here is the last table that shows the normalized design rainfall temporal pattern for region 2 at Johor and other states. I think that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Zaida binti Zamri. My metric number is AF220146. Now I'll present the data analysis, which is the peak discharge. But first, let's take a look at the case study area. The first picture shows the case study area that I took from Google Earth Pro. This red line here indicates the drainage being investigated. Next, by using the same software, I calculate for the catchment area and I get 12 hectares as shown in this second picture. This third picture shows the elevation and length of the drainage also by using Google Earth Pro. It is not clear here, but the highest elevation is 10 meter, the lowest elevation is 7 meter, and the length of the drainage is 484 meter. The last picture shows the cross-section of trapezoidal drainage. From the site visit, we get the bottom width is 4.5 meter, the top width is 5.7 meter, and the depth of the drainage is assumed at 1.5 meter. Combination of discharge, cubic. For the calculation, step 1 is to calculate the catchment area. We get 12 hectares. Step 2 is to select runoff coefficient. Then use is commercial and business center, and ARI is more than 10 years, so we get the runoff coefficient as 0.95. Step 3, determine the length of ridge to calculate time of concentration TC. The length of ridge is equal to the length of the drainage, and as I mentioned before, the length of the drainage is 484 meters. Step 4, calculate area of the channel, which is trapezoidal in shape, with side slope 1,3. From the site visit, the depth of the channel is assumed at 1.5 meter and the width is 4.5 meter. So by using this formula, we get the area is 13.5 meter square. Next step, step 5, calculate weighted perimeter of the channel. Using this formula, we get the weighted perimeter is 10.5 meter. Step 6, calculate hydraulic radius. Using the formula R equals to area over weighted perimeter, we get the hydraulic radius is 1.2857 meter. Step 7, determine the friction slope of the channel by dividing the difference in elevation by the length of the channel. A small mistake here is supposed to be 10 minus 7 over 484. So we get the friction slope 0.0062. Step 8, calculate travel time in channel TD using n equals to 0.050 for grass drain with tall grass cover. So we get travel time is 4.33 minutes or 0.07 hour. Step 9, calculate rainfall intensity. Using this data, nearest station Setor JPS Batu Pahat, ARI 100 years, and travel time, we get rainfall intensity is 417.43 millimeter per hour. The last step is step 10, calculate the peak discharge, cubic. Using this formula, we get cubic is 13.219 meter cube per second. Thank you. That's all from me.
Assalamualaikum warahmatullahi wabarakatuh, and my name is Shamsul Kamar bin Abu Bakar, and my number metric is DF210029, and I will present about the proposed new design of channel section. Based on the calculated and analyzed data, the cause of flash flood in the area is small area of the channel and too shallow. Therefore, to prevent the flash flood, From occurring continuously, the channel perhaps can be enlarged and deepened, so it can raise the flow of the water more than the peak of flow, which is 13.219 meters cubed per second. This is the proposed design for the channel as the cross-section trapezoidal drainage. From the analyzed data from the Q peak, we get the bottom width is 4.5, same as we analyzed, and the top width is we improved at 6 meter from 5.7 meter from the analyzed data, and the depth is 3 meter. We increase from the analyzed data, which is 1.5 meter. For the calculation, same as the Q peak that my friend has presented, step 1 is calculate the catchment area, and we get 12 hectares. Step 2, select the runoff coefficients. The land use is for commercial and business, and the center, and the ARI is 10 years, so we get C as 0.95. Next step is step 3. As I said just now, the length is 484. Step 4 is to calculate area of the channel, which is the trapezoidal shape, and the ratio that for the side slope is 1/3. From the analysis that we get from Q peak, the depth of the channel is predicted at 3 meter and the width is 4.5 meter is the best. The area which we get the area is 27 meter cube. Meter square. And step 5 is to calculate with the perimeter of the channel. Perimeter that we get is 10.5 meter, and calculate the hydraulic radius. Step 6 R, which we get 2.5714 meters. And step 7 is determine the friction slope of the channel, which is S, by dividing the different elevation by length of the channel, and we get 0.0062. Step 8 is to calculate travel time in channel TD, and we use N 0.05 for grass drain with tall grass cover, and we get the TD is 2.73 minutes, which is also D 0.0455 per hours. And step 9 is to calculate the rainfall intensity, which is in the nearest station, Setoraja PS Batu Pahat, and the ARI for 10 years is TD. The I that we get is 417.43 millimeter per hour. And the last step is to calculate design discharge, which is Q design, and the Q design that we get are 14.382 meter cube per second. And since the Q design is larger than Q peak, meaning that the proposed new design of the channel section is passed. Thank you.
Hello, my name is Mohammed Idris Yusuf. I'm here to talk about our group project discussion. Based on the project requirement, we selected road drainage as the method for reducing flooding in Taman University Baracha area. To assure the quality and public safety, we designed the road drainage based on the upstream drainage area. The levels of the water availability table, past drainage patterns relative to way or assessment that are accessible and brand convenience. An action that can be performed to prevent the flood from happening again is known as flood mitigation procedure. Both structural and non-structural methods of flood control are possible. And now, factors of flash flood. A flash flood is a sudden intense that occurs within a short time period, usually less than 6 hours due to heavy rainfall or failure of dam or leaf. Factors that can contribute to flash flood include soil type, heavy rainfall, land use, and topography. When heavy rainfall occurs in these areas, the water is unable to infiltrate into the land and instead runs off the surface and quickly clean the streams and rivers and causing them to overflow. And now the flood mitigation method. Flooding is the deadliest, the most expensive and most common natural disaster in the world. The use of floods and levees and flood walls, seawalls, and evacuation routes are examples of structural forms of evacuation or mitigation. Since the levee is made of crushed dirt and additional land is required, levees are dams built to keep water away from agricultural land and commercial sectors and urban areas. Levees are utilized when the land is at risk, flooding from rain or melting snow. Levees can be built from sandbanks, earth and or cement. Rivers are other significant rivers in the states. Levees are used property owners in this river to utilize levees to safeguard their lands. Now, feasibility of the method. The feasibility of the mitigation method for flood damage depends on the number of factors, including the specific location and type of flood risk, as well as the availability of resources and funding. The use of levees and sandbags can have several advantages as a method of mitigation of flood damage. Levees can be relatively inexpensive to construct. They can build to provide protection against a specific type of flood or water level, such as 100-year-old flood. Sandbags can be easily placed by volunteers or community members. Sandbags can also be used as a temporary measure, which means they can be flood risk past.
Assalamualaikum, I am Rukaya Agusya binti Cik Azlan. In conclusion, by designing the urban drainage design, the fundamental knowledge of engineering is important and used, which also includes the basic science and mathematics knowledge. All of the previously specified objectives were met by referring the second of Urban Stormwater Management Manual for Malaysia MSMA. Urban water management are being driven to use a number of sustainable strategies as a result of urbanization and climate change. The availability of trustworthy hydrological data as well as the ensuing vigorous activity would have an impact of urban flooding and climate change. The rational method, which uses a proportionate ratio to connect peak runoff to rainfall intensity, is the fundamental method that has been used to compute stormwater flow from rainfall. Furthermore, the drainage system proposed is appropriate because, according to the preceding calculation, its peak flow is less than the allowed discharge. The drainage system has been examined and confirmed to meet all of the design standards. If the drainage system is continuous and fits the drainage system design standards, it will flow by gravity from upstream to downstream. As for the recommendation, as previously noted, local authorities play vital roles in keeping the natural areas safe and clean. They must prepare for the heavy rainfall, and the drainage system must be capable of handling excess rainfall that may overflow, allowing excess water to be drained out. That's all from our group. Thank you.